Hello, everyone, and welcome to another VES-Artex Academy webinar. Thank you for joining us on this lovely Friday. Today, we are joined by Terry Canning, the CEO and co-founder of CattleEye, and today he's going to present Computer Vision, the New Frontier in Precision Farming. Before we go ahead and get started, I just want to let everyone know we will be accepting questions throughout the presentation. You can type them into the Q&A box on the bottom screen in your control panel, and then we will address them at the end of the presentation. So with that, go ahead, Terry, the floor is yours.
Thank you very much, Annie, and good evening, good afternoon, and good morning, wherever in the world you all are. And thanks very much for tuning in to today's webinar. Thank you very much for VES-Artex for inviting me along. I'd like to start off with a quick poll, just to get an idea from the audience. Which of you would believe that computer vision, or expect that computer vision could eventually replace all wearable technology in dairy farm monitoring? So that's the sensors, the various wearables, the collars. I'd love to hear from the audience to see who that, or what your thoughts are on that. So if you can run that poll.
Yep, we'll give it just a few more seconds for everybody to go ahead and answer.
Okay, cool. And in the meantime, we can look at the results later. But in the meantime, I usually start these things just by presenting a little bit about my background. I grew up in a dairy farm in Ireland. I was the second son, so I was sent off to college. I went into academia, and I graduated as an engineer. And I worked for 9 years in various telecommunications companies around the world, focused mostly on cloud computing. And I learned how to develop cloud-based applications. And in 2004, I went back to the farm, back to the livestock industry, and applied my knowledge of cloud computing to found the world's first software as a service for managing livestock called FarmWizard. So I grew that up over the next 10 years until we're managing about 4 million animals worldwide. And I sold it in 2015, exiting in March of 2019. And it was there I became very familiar with the problem that we all face of how we get better data from farmers about their livestock. And we need that better data to be able to improve genetics, make better genetics decisions, to improve efficiencies on the farm, and also to monitor and improve animal welfare. So currently the way this is done is, let's close that up. Currently the way that this is carried out is, first of all, primarily it's carried out by human beings. Human beings do most of the manual data capture, human observers. So the issue with that is humans find it difficult to do mundane, repetitive tasks, such as watching lots of animals walk past them. So whether they're mobility scoring, locomotion scoring, body condition scoring, that's difficult for human beings to do because it is so repetitive. And they can also make mistakes. Now, wearable technologies have really helped the industry so much. The devices that you attach to legs, to collars, really help the industry so much. But they require configuration, they require attachment to devices. Now, there are some computer vision solutions out there. They're primarily based on 3D technology. It's again fabulous stuff, but it's expensive for those 3D cameras, complex to set up, and typically very bandwidth heavy, which is a problem with dairy farms. So what we've done with CattleEye is develop technology that uses 2D low-cost security cameras. So these are just security cameras that you might have on the farm already. They're maybe $150 to install. And what we do is we take that video footage, we run it up into a cloud network, and we analyze that footage to derive insights, and we give those insights back to the farmer. Now, our first delivery, our first commercial release involves locomotion scoring and lameness detection. And for that, what we do is the farmer puts up the camera as the cows are exiting the milking parlor. So the cows walk past the camera during a milking. We then pull that footage up into the cloud. So we don't do it in real time. We upload once a day with the milkings. And we then start to run it through neural networks. Now, neural networks, they're artificial intelligence networks that we've spent the last 2 years developing. Typically, we train those networks using cows that walk past the cameras. We then use ground truth veterinarians to score the cows. and we use those to train our network. So the neural networks will, first of all, find the cow, because you're starting off just with video footage. Find the cow, identify her, because you've got to be able to tell the dairyman or dairy woman which cow they need to take action on. And then it looks for key points. And it's these key points that we feed into final neural network, which then gives us a locomotion scoring for the animal. Now, the farmer can then take action on that, and typically it's just hoof trimming. So what we do is the farm will use our technology to work out their hoof trimmer list. And what we do with CattleEye is we provide an app, and I'll give you a demonstration of the app. But we also integrate with Dairy Comp, and as of this evening, BoviSync as well. So we're really excited, because we want to exist, and we don't want to introduce new systems for the farmer. We want to integrate what they've already got. So our system itself is, our first release is aimed at reducing lameness levels on dairy cows. Now, there's lots and lots of analysis carried out on how many lame cows there are, and it can, in some reports, put it as much as 30 to 32%. So that's a very, very high percentage of lame animals on a particular dairy. And the costs of that, they think about $3 per cow for every day that a cow is lame. And that's because she's less likely to get back in calf, she's producing less milk. So really, it's a big problem, and it's therefore it's an opportunity. The experts say that for every three cows, there's 3 to 4 score 2 cows. So really, when a cow becomes lame and it's noticeably lame, then it's a little bit late. So what we aim to do with CattleEye is to provide early detection, so that farmers can very quickly provide prompt, effective treatment. And focusing very much in the first lactation as well, we really emphasize that if you can get in first lactation, you can make a big difference to that cow's future lactations, because if they get lame early, then they tend to become chronics. So the early detection is very, very important. And if you look again at the dollar value of lameness on cows, as I mentioned, the $3 per cow per day. So if you let's say you're a pretty reasonable herd and you're operating at 15% lameness prevalence, so that means that every day there's 150 cows. Assuming your dairy farm had 1,000 cows, that would be 150 cows. So that's a lot of money that's being left on the table. So $150,000 per year. So what we've been able to demonstrate on some of our farms is a reduction of about 10%. So if you can reduce that by 10%, then you're saving about $100 per cow per year, or for $1,000 cow, $100,000 a year. So there's a really clear value proposition to detecting lameness. Now, we've been running since we've brought in our first dairies about late 2021, and we've been doing lots of analysis. And what we do is we score the dairy cows, the lame cows. We give them a score between 0 and 100. And the higher the score, the more lame the cow is. So this is some analysis we've done by pulling out some dairy comp data off a farm, comparing it with scores. And what we see is the CattleEye score tend to creep up prior to the actual lame treatment occurring. And you can see these 4 graphs are really good examples of where is if the dairyman or woman had operated early, it tends to stop the cow going lame in the first place. And we're really excited whenever we see this type of results. And that's really our core being, and where we want to get to. We want to be in a position to detect the cows that are going to go lame earlier than the human being can detect them. And we're really excited about that. Right, I'll give you a sort of a demo of some of how the cows are scored. This is quite a good little video that we set up whenever we had our first algorithm, which was in sort of late 2021. We recorded this video, and what you're going to see, you've got your two videos there. One is just a side view, and that's just for demonstration purposes. The bottom camera there is the CattleEye camera, and it's just scoring the cow from above. Now, the table you see on the right is 6 cows, and you'll see score 1 and score 2 are human beings. Score 2 was on farm, score 1 was scoring remotely via video, and then you see the CattleEye scores. And as I mentioned, we score between 0 and 100. The scores there are using the ROM score, where they score the cow either 0 if she's absolutely perfect, or 3 if she's lame, and 1 and 2 degrees in between. So if we kick off the video. So the first cow comes through, and one of the scores missed that she was lame, and CattleEye picked it up. So the next one, she's marginal. CattleEye still thought that she would be worth a look at a high score. And the third one was fine. Everybody agreed that cow was walking perfectly well. Now, there's a bit of a delay in this next cow, and that gives you a little bit of a clue as to what's happening. You'll see this cow walking quite lame. She's very lame, in fact, and you can see that quite obviously from the cameras, even from the side. And the algorithms had picked that up and scored her as a 63. So very much a cow that needs intervention. And the next two you'll see walking through are pretty much fine. Just one more to go. And she's walking perfectly well. 25, nice low score from a CattleEye perspective. So as I mentioned, I started the business in 2029 along with Adam Askew. And Adam, he wasn't from an agricultural background. He was from technology background in the human healthcare space. And he had worked for a company that was developing cancer detection technology using image analysis. So we raised our first investment at the end of 2019. And then we recruited a number of his team members. So we had a good team of experts to start to. And when we spent 2021 building the first algorithm, which involved walking about 10,000 cows on a regular basis past cameras and veterinary experts giving us those scores. And we used those scores to ground truth and to build that first algorithm. So at the end of 2021, we put our algorithm out for external validation. So we've had various engagements with academics. The first one was with the University of Liverpool, and it was about 1,400 cows on 3 different farms in the UK and the Cheshire area. For 12 weeks, there was human beings, the expert veterinarians would go in and score the animals, and CattleEye would score them. And at the end of the study, the results were compared by a separate academic, and what they concluded, and we'll see some more graphs in this in the next slide, but really the CattleEye was pretty much as good as a trained score. So it agreed with each of the trained scores, the human veterinarians, as much as the veterinarians agreed with themselves. But really excitingly, whenever it came to actually detecting lesions, CattleEye outperformed the experts, and we were really excited about that. We were more sensitive, more specific at detecting lesions. We also ran a study with Gerard Kramer and the University of Minnesota to work on how the intervention should occur whenever the CattleEye score tended to trend up, and this was before the cows were lame. So what we did was CattleEye would produce a report of all the cows that were trending in an upwards manner, and some were treated and some weren't. And they found that the ones that were treated had a more favorable outcome in 14 days after treatment. So we really want to build on that. CDCB have also done a little bit of work on analyzing our locomotion scores, comparing it with some of the on-farm data that they're seeing. And they see on average a 12-point higher scores for cows with lesions on the 100-point CattleEye score. So all really strong validation from a lot of experts in the market, and we're really in the industry, and we're really excited about that. A little bit more in the validation study, you'll see actual lameness prevalence from the different assessors versus CattleEye on 3 different farms. And you can see that roughly they're pretty much the same each time, a little bit of a variant. Area under the curve, 0.832. So nice, good level of analysis. In terms of then how we go to market with the system, so really CattleEye is producing lots and lots of data, and that data isn't just useful for the farmers. It's actually useful right across the supply chain. So if you're a genetics company and you want more phenotypes to be able to build better genetics, then you can use our data, because we can collect data at high levels of data at a very low cost just by using our video footage. Also for nutrition companies to be able to demonstrate that the impact of nutrition. We're working with a couple of well, one nutrition company in particular at a sale around how their nutrition products can reduce the lameness levels, and then tracking that using CattleEye, which is very exciting. And also health companies as well that of course want to monitor the health levels on the dairy. So we can provide the input providers with high levels of highly accurate data at a very low cost. So that really makes an impact there. And then downstream from the farmer, where you have processors and retailers using that data to help predict volume, or for the retailers to be able to demonstrate to their clients, to their consumers, that they are maintaining high levels of animal welfare among their supplier base. So we're taking an approach very much across the supply chain. Now, as well as the validation, we've also had from the academics, we have good support from, first of all, the retailers. Tesco in the UK have about 800 direct contracted dairy farmers, and they pay cost of production plus model for those dairy farmers. And they take real pains and they take real effort to make sure that the farms that are supplying them are operating at a high level of animal welfare standard. So they engaged with us really early on and have really helped us find farms to work with us from the very start, introduce us to people like the University of Liverpool to help build our application. Another really important study was on a farm in Wales. It was a 400 cow dairy, pasture-based primarily, and they were running at quite high lameness levels of 25%. So they worked using the CattleEye score along with the University of Liverpool to identify the right cows to be trimmed, and they managed to reduce lameness levels from 25 to 13%. So we were really, really happy about that. So we're starting right now then to roll out the system among more farms. Now, if you look at where our customer base is, we started off in the UK, and that was through working through our retailers, but also in the GCC, some of the larger dairies in the UAE, also in Saudi, but really, really importantly, the US market. It's really providing us with a lot of traction. You've got a lot of large dairies there that haven't maybe adopted wearable technologies, but do require some way of individually managing cows and monitoring those cows. And we've been working very much finding biggest traction in the US, and we're really excited about that. Now, one of the initiatives that we've carried out along with our partner in the market, Hoofstrong, is to build an ecosystem, because of course there's no point if we're just collecting locomotion scores and farmers aren't doing anything with it. And so what we really need to do is to provide a system whereby we integrate with all the other stakeholders around hoof health. So I mentioned we integrate with Bovisync and DairyComp. We also work with All for Hooves. So Hoofstrong, who are our primary route to market for our lameness product, are providing this service, this wraparound service, where they'll provide you with the hoof bathe, the trimmers, the CattleEye, all linked together so that you can see a result. And we think that's really important because there's really no point in us just collecting data if the farmers and we don't carry out the intervention, or else we won't see the value. And we'd like to replicate that in other regions as well. So Hoofstrong are focused on that for the US, but we'd like to do something similar in the UK as well, with similar partners in those markets. So I mentioned before about what's required for actually if you wanted to deploy CattleEye. And one of the brilliant things about the system is it's very, very low cost to deploy. It's very simple. It just requires one camera. In some cases, sometimes it requires two, but in most cases it requires one. And you're talking about $150 power over Ethernet box, HD card, some Ethernet cabling, and you can pick that up from Amazon. And you then need to position the camera in such a way, it's about 9 to 12 foot, and with 3 to 4 meters of walkway. We need to see the cow walk for about 3 meters before we can actually score her. So we need to find those points. And usually it's usually around the exit race of a parlor that we'll be able to see that we'll be able to position the camera and then once you connect to the internet, then it comes up into the CattleEye cloud, and then that's where the analysis happens. Now, there are different configuration of farms that we support. If there's maybe if it's a rapid exit parlor and they don't have a sort gate, what we can do is we can put in panel readers. So the cows, this is how we use our identification. That's how we identify the cows. Cow walks past the panel reader, we scan the ear tag, and then at the same time we mobility score. We put the two together, and then we were able to tell the farmer which particular cow that they need to take action on. Now that works well in a single lane exit, but on the wider lane exit on a rotary, what we can do is we can use a 2-camera solution. And really what the 2-camera solution does is it takes a picture, if you like, of the cow as he's stepping onto the rotary, and then correlates that cow's score with the RFID reading in the milking parlor, rotary. We have a lot of really clever technology that isn't just reading or lifting up the scanning, it's actually saying, well, what did we see yesterday, and is it the same one? And because there's lots of issues with RFID on a rotary parlor where maybe some things aren't red, sometimes the cow is not red, something like that. But we've built enough smarts in there that we can really accurately identify a cow about the 3rd time that we see her. And then later on as she exits, so whether it's a wide race, so long as there's a 3-meter walkway, it can be wide, can be single lane, we can then analyze the cow. And that's that's a solution we've had out for quite some time. The other way we do it is we just talk to the sort gate. So if you've got a sort gate in place, it's pretty much the easiest solution. You just need your 1 camera, and that one camera will then tie back to the RFIDs, and through time it will learn to recognize the cows, and then it will then be able to produce the scores and pass those back to the dairy farmers to be able to carry out the intervention that we need. So those are our supportive configurations. A little history of the company and where we are right now is just on this slide. And as I mentioned before, we started in 2019. Myself and Adam has experience in computer vision for human healthcare. Then 2020 was really all about building our first algorithm and just collecting thousands and thousands of human mobility scores, finding a way to take the machine vision onto then you do it such a way that we can do that mobility scoring. And we had that particular approach that we did to mobility scoring, we had patented in 2020, and we had the validation study. And on the back of the validation study, at the start of 2021, we raised more investment, which allowed us then to grow further and to keep growing. So we've got about 40,000 cows live right across the UK, US, and GCC. We've had quite recent success in various grants in the UK and both in Europe. Our plan is to build a body condition scoring insight within the next, we should have that ready within the next 3 months. We'll be planning to fundraise in the second half of this year. We need to move to the edge compute. One of the, I guess, the limitations of our technology is that it requires you to upload footage from the farm up into the cloud for the analysis. Now that kind of works well if you've got a really brilliant internet access, or you can wait to the next day. But if you want to carry out interventions and insights quickly, you really want that to be done on the farm. And that's really where we're moving to for the edge compute. Other type of projects that we want to get involved in are poultry and beef projects as well. So we're looking at some work with that's being supported by McDonald's and our local university around using this technology for monitoring chicks, and also a solution that would look at potentially analyzing when the right time it is to harvest a beef animal. So you can analyze the animal as they're in the camera and work out when is the best time to optimize to harvest that animal based on lots of other previous data that you've collected up. So that's the history of the company and where we are. And really where we're going to with the system is right now we're in the milking parlor. And in the milking parlor, the cows walk past, so you can mobility score them, you can body condition score them, but you're not knowing what's happening outside of the parlor. And we intend to introduce a barn solution in the next 23, 24, put up more cameras around the barn, be able to, for example, work on cow location. If we could analyze where the cow is and identify where the cow is, looking at lockup times. Be great if we could do heat detection as well, estrus detection, heifer weighing, cow budgets, heat stress. It's really the direction that we want to go. Meanwhile, in the milking part, we will continue to build up, but our focus is very much on the individual animal. We're not looking to get into protocols about people or anything like that. We really just want to focus on the animal itself and really work on how we make that animal more productive and helping the dairyman or dairy woman make better decisions on that. And if I'm just going to one slide that I've seen about why we do all this, and really you look at I thought this was a really great picture that somebody showed me just yesterday, but it was really showing that whenever by making the cows more efficient, and of course genetics plays a big part in this, but also at a production level, being able to make the right decisions is going to be really, really important to help increase that productivity. And this is the results. If you look between 2007 and 2017, how much US milk yields have increased. But that has such an impact on the environment because you're using up so much less feed, 17.3% less feed. There's less land required, less water, especially these days, less fuel. And I think the carbon footprint side of things is really important as well, is that reduction in the carbon footprint, much lower than it was in 2015. So with that in mind, I'd like to see the results, Annie, of the before we step into the demo. I'd like to, can you flash up the results? I'd be very, very curious. Oh, yes. Good. That's good. Yeah, that's nice to see some good confidence that, well, we hope we won't let you down. Cool. So that's 74% if you think that we can do it. And 6 won't. Yeah, I'd love to hear some questions or some comments. Actually, in the guys that thought no, if you want to put anything on the questions, we can cover them. So what I'm going to do now is I'm going to do a demo of the system. And as I mentioned before, the primary interface to the system will be via the farmer's own herd management system. But we do have an app. And I thought I just wanted to show this to you actually, of what the farm can actually see. For the lameness system, what we do is we give an overview, a herd overview of how of what's happening on that farm at any one point in time. So you'll see over time. This particular farm is quite interesting. The lameness levels are heading up. That could be because of a new foot trimmer, could be for a number of reasons, but we'd certainly want to get looking on that one. You'll see that we show the lameness prevalence level. You can see that going up, sort of sitting steady, and then it went up. We show a breakdown of the 0s, 1s, 2s, and 3s, the ROM scores, and you can sort of get a handle there that there's been a bit of an up set of 2s, definitely more 2s coming up. 3s are pretty much the same, but there's definitely an increase in 2s, so a lot of 1s moving to 2s. So that gives a really good overview. You can see the number of animals that the system is monitoring for you. You can look at the number of lame ones, the ones with the mobility score trending up. So to talk to you a wee bit about what these and how you would actually interact. So if we click here, you can go in and you can actually see the cows that are having issues. Now these ones, some of these will be lame already, but not all of them. Some of them may be about to go lame. These little icons, this one's a newly lame one. She's trending up, and she's just gone over 50. So that would say here's 57. But let's have a step in and we can click in, and then we can see this cow that she's had some problems in the past, where you see her scores gone up way back in March, came back down again, it went back up, and then it's taken a big jump up. So you can then take action on it. So let's have a look. So you can pretty much see her as she's coming out. And you can see her. She's just not that lame, but she's definitely getting worse than she was. So again, you look at that cow, think maybe she wasn't lame, but the fact is CattleEye has been maintaining our history. So we have our history on that animal. So we can see that she is definitely worth having a look at, worth checking on. Let's go and see some more. If we go, let's look at a sort of a pretty lame one. Now this one, this tells us this one's a bit of a chronic, frequently lame. Let's have a look at this one. And she's very interesting because she's been fine historically. She's had a little bit of trouble around April, and then things got better, but now it's shooting back up again. So you can see how from May she'll have been on the CattleEye list for quite some time. And you see pumping up, going up through space. And let's, if we watch the video here. You can see that she's pretty lame. That's pretty obviously lame. Usually when they're getting up to that type of lameness level, 78, you can see it's pretty obvious that that cow's having issues. Let's see if we have a look at a couple more. We've still got plenty of time. Let's see if we find one that's maybe, yeah, this one's not lame yet, but it's heading up. Let's have a look at this one. It's gone up. Well, there's one there heading up quickly. She's gone up to 36 quite quickly. Let's have a look. Again, totally fine, heading back up very quickly. Definitely one that you want to have a look at. So you can see, and what you can, I mean, we have other forms that we can show you some stuff on as well. If you see the lameness levels here in this one, so this one's a better performing dairy, still some trending up. We can have a look at some of the ones here. So if we see this one, so this one is newly lame. She's trending up, and she's definitely lame. She's over 62. So like, you'll see how clever this is. This is a good example of how clever the system is at being able to deal with bunched up cows. So it can still find them as these cows are moving through. They can still pick, and that's been a lot of work from our side to make that happen, to make that possible. So if we try 4, let's see, it's probably more than 1 instead of 3. See, that one's probably a little bit more chronic, a bit more often. So you can see that. So with that in mind, I think we're finishing a little bit earlier with, have we any questions through yet, Annie?
Yeah, one question was, so you showed some examples of how the technology captures cows going to the parlor. How does it work with robots that are maybe not really leaving their very small area?
Yeah, it's a really good question. We have been looking at a robot solution with one of the robot manufacturers. It's trickier because really, if you don't have a place where the cows are walking past, it's very hard for us to actually score them. So really, really, it's tricky. Now, there are solutions. So a lot of what we can do is we can monitor the cows then when they're in the passageway. And that requires us to move then to the different solution because we need more than one camera. We're going to need more bandwidth. So we do intend to be able to monitor the animals when they're up there walking up and down the passageways. The other is looking at the guided robots. So there are new technologies for some of the larger dairies that involve guided. So there's still a guided exit point. So the cows aren't totally free flowing. That could be an easier one for us. But right now we're very much focused on rotaries, herringbones, and rapid exits with a single lane passageway. I mean, there's a heck of a lot of dairies out there with that setup, and that's our focus for now. But it's a really good question, and it's one that we know we need to address because there's such a move towards automation. And I think with all the various labor issues, all the messages we're getting from the dairies is we're going to be going robot at some stage in the future. So we know that we have to develop something at some stage.
So what size dairies would this kind of service be useful on?
Yeah, so any dairy basically with more, I would say more than 50 cows. So the good thing about the technology is it's very low cost, so it does not require a large capital outlay. So even a small dairy can use the technology and they can pay for the camera and they can then start to pay. We charge a per cow per year fee of around $1.50, $2. Sorry, per cow per month fee of around $1.50, $2, but drops as we hit scale. So if you're a smaller dairy, you can invest a smaller amount, and then the system will work well for you. But we can then scale all the way up, and we have all the way up to 12,000 cow dairies that we're looking at getting the system up and running on.
So since there's no wearable on the cows, how does the system learn them and then find them again?
Yeah, so that's a really good question. What we do is we're looking at the visual representation of the animal. We probably go back here. All right, should we flick back? Yeah, it's really how the cow looks. So you're taking color is an important part, but also the cow shape. Even the way she moves as well is something that we add to our identification. So in the first instance, we use its RFID. So I guess, yeah, you can see the RFID, the EID tag is a wearable from an identification perspective. So whether it's they're identified at a panel reader or when they're stepping on a rotary or they're exiting a sort gate, we are using the identification to map our visual representation of the animal to a particular ID. And that's a good, you can see with these cows here, you can see how they're very, very different. And we will, in this particular case, this is a rotary farm. So we will have seen that cow stepping onto the rotary, identified and learned how she looks, so that when we see her in the other camera, we can then identify her. And it takes something like maybe to see the cow 3-4 times with that RFID before we'll be absolutely convinced it is her. But once it is, every time we see her, we're able to identify her. And we constantly, if you think about how these our configurations work, let's see. If you look at these, so this is one where the panel reader is right over the camera. So it's just it's very simple because it's a timestamp. This one, it's 2 different cameras, and in most cases the RFID will not be under the camera. It can be hanging. If you see the rotaries, the RFID readers hanging up, and it really doesn't. There is no accurate timestamp to that when that cow actually is scanned. It's feature of most parlors that they don't need it to be exact. They just need which cows in which stall eventually. But we can use that information flow, whether it's from Bomatic or from IKEA, to then again know which cow and map her visual representation into our database. So when we see her back down here, we can then actually do the analysis. This one here, again, it's simpler. It's a sort gate, so you're only needing 1 camera. But again, you're using the RFID to help the camera learn and to represent to give that animal a real ID as opposed to just some sort of an internal computer system. But yeah, but we use the RFIDs to first of all learn the animal and then to feed that back to the farmer so they carry out intervention.
Who owns the data generated by the system and how do you keep it secure?
Yeah, so the farmer owns the data. We're very clear about that. We keep it extremely secure. Our systems are monitored by AWS, and then we've been through a number of audits with a well-architected review. We've gone through pen testing. We've done a lot of stuff with third parties because the data is so, especially with the videos, we need to keep those videos very, very safe. So we take that very, very seriously, and we're quite close to becoming a full partner of AWS, which again is another tick in the box to say that these guys know what they're doing. They have the data highly secure. But yeah, so we would the farmer would own the data, and we can even help. There are cases now. I mean, remembering that we're very early to the market and looking at different business models, but we do think that we're going to be able to help farmers sell the data in an anonymous fashion to genomics companies that to actually help the industry, because again, this level of data collection really hasn't been possible before now, unless you're attaching devices to each cow. But this volume of accurate data is so exciting to everybody else in the industry as well, that you can really help the dairymen and dairywomen make money from that as well. So we're really excited about how we do that. But ultimately, they own the data, and we do nothing without their say.
Can you elaborate a bit more on the ability to measure heifer weight? Is this in terms of BCS or actual weight?
A really good question. We're doing BCS first of all, but we think there's a real opportunity for heifer weights, because I think knowing the right time to actually breed a heifer is dependent on conformation, the weight, height, etc. So really, it's a prioritization thing for us. We'll be doing body condition score first of all as a separate insight, and that's coming out soon. But we will be looking to do heifer weighing as well, and that's, I won't use the word easy, but it's relatively straightforward using an overhead camera. Where we want to be is the masters of the overhead camera, to build our heifer weights. And really what we'll do there is it's the same process. It's machine learning, artificial intelligence, lots and lots of data. So if we have enough animals walking past and we know their weights, the algorithm will learn how to be able to do the weights without the weight. So we're really excited about doing that.
And that's the last question that I have.
Okay, cool.
Oh, just kidding. 2 more just came in.
Yeah.
How do you handle the internet speed on a farm, as not all farms have good internet speed?
Yeah, that's a good question. Right now we require, and I think on this one we'll see it, we require everybody to do a speed test. Now, really, depending on the herd size, we would, if it's a big dairy and we need to use the 2 cameras, that's quite a lot of data. So you need, say a 4,000 cow dairy, you'd need about 4 meg up is what you'd expect and what you need. On a smaller dairy, it's, I think probably our most efficient use of broadband is in a 700 cow dairy with an 0.7 meg upload speed. And that's, I don't think we'd go any further with that one. That it's factors such as how long it takes to milk the cows. It's obviously a factor of the size of the dairy, but also it's cow flow as well. So it's, if it's a large dairy and they're milking all the time, even with good cow flow, you probably need about 3 to 4 meg upload. Smaller dairy, maybe you get away with 700K would be the tightest. But even on this particular dairy, I know we annoy the dairyman's kids all the time when they try to watch Netflix when they're uploading it. But we can time the uploads to happen outside of whenever the farmer is doing the milking, whenever they're doing the we can do it like at night, 12, whenever nobody's watching the TV or nobody's watching their Netflix, so, or ordering from Amazon. So we can do that so that it doesn't interfere with the family.
Are there more modules like heat detection, lying time, eating behavior, etc.?
Yeah, absolutely. That's where we want to go. Right now, if we go back and sort of think about our product roadmap, right now our cameras are in the milking parlor. So they're in the milking or the milking barn. We call them parlors this side of the Atlantic, but and that's the two cameras whenever they're coming in to be milked or exiting the milking parlor. And from those, then we can do lameness mobility score, body condition score, weight, rumen. So just as the cows are exiting. But if we really want to get into heat detection, estrus detection, cow budget, we need to go into the back of the barn and bring our solution into the back of the barn. And we can see, you know, we're pretty sure how we know how to do that. We can put up cameras in the barn, analyze there. We can look for the cow location, so we can learn. So we know what the animal looks like. She's exited the parlor. We've got her ID. Then we can track her all the way back through, and then monitor for the rest of the day. So that's where we want to go. But you're talking next year, the year after, before we'll be able to do that, or we really want to become masters of the milking parlor first of all.
Is it possible to play on the number of frame/seconds taken by the camera to manage the internet speed needed?
Sorry, what was that question? That's not really good.
Is it possible to play on the number of the frames taken by the camera to manage the internet speed needed?
Oh, that's a really good question. That's a good technical question there. That's pushing my knowledge, but I can handle it. Yes is the answer, and where you have to balance it is you need a certain number of frames. So it's frames per second. So if you set the frames per second to be really low, then you uses less bandwidth. So you're taking picture after picture. But there's an optimal number of frames per second that we need for our algorithm. So right now that's 10 frames per second. We have actually looked at dropping it a little bit further. So we've I think we've done some experiments on a 5 frames per second, which is half the bandwidth needed. It's something that we certainly look at, but we need the balances. We need the certain number of frames to be able to accurately mobility score the cows.
All right, well, with that, I do not have any more questions. So I think we are good to wrap up. Thank you so much for your time, Terry. If you wouldn't mind, thank you so much. We would like to invite everyone to our next webinar, which will be on Friday, July 8th with Dr. Mike Wolf. He'll be speaking on keeping cow comfort consistent in an animal-centered environment. So thank you so much, everyone. Have a great weekend.
Thank you very much.